Welcome to functions. A function is a way to reuse code by dividing it into blocks. Code inside of a function runs only when the function is called. There are two types of functions. There's a built-in function, and these are the functions that come with Python. They're built into Python. They're also called predefined functions. We've used some of these already. Examples of these would be the range function, the type function, the string, and the print functions. User-defined functions are functions created by the programmer themselves. User-defined functions can be part of the program or saved in separate files called modules. Let's take a look at a simple function. A function only runs when it is called. Data, known as parameters, is passed into a function. Functions are used to perform a specific task, and functions allow code reuse and simpler programming. So let's take a look at this in VS Code. In VS Code, I've gone ahead and written the program add.py, and the first line of code is going to define the function. And what this line does is it creates the function name, and then it creates the parameters that the function are going to use, or the arguments. Depends on whose book you read, but in this we'll call it parameters because that's what's highlighting in VS Code. And now I have my function body, and that's these two lines of indented code right here. And what my function body is going to do is it's going to do something to my parameters. This is the actual task that the function does. And then the next thing it's going to do is it's going to pass the result back to the function call. And here's my function call right here. And then we're going to actually print it so we can see the result. Now, one thing we need to think about with functions is this add line, line 1, does not execute until I call the function down here at line 5. But line 5 can't execute unless the function already exists. So I have to put my functions before my function call, and I'm going to turn on debugging for this, and we can take a look at it. But the actual first line of code that's going to execute will be this. Now I guess this line will execute because we will declare the function and it will be in memory and accessible. But these two lines, lines 2 and line 3, these aren't going to execute until we get to here. So let's take a look at the flow. So I'm going to go and I'm going to run this in debugging mode, and I'll choose the Python debugger, and that's what I'll run. So as we go through this, it starts the program and our first line of code executes. Now we go to line 5. And then when we call the function, we go to the actual function body, and we passed these two values, 3 and 11, get passed into the function call, and they become A and B. Then we go to the next step, and it's going to now return the result. We don't actually have X yet. It's nothing. We know that the result is 14, but until this line executes, X is nothing. So the next step, now X became this. Not quite sure why it didn't pause here. Never mind, it did pause there. I'm getting myself confused. So now X is equal to 14, and then when we execute this line of code, we'll actually print that and see our function work. Now in a function, I can pass values either as values or as variables. In the example on the left, I've declared two variables, weight1 and weight2. Now when I call the function, I can pass the variable names, and when those variable names get passed into the function weight1, the variable weight1 doesn't really get passed. These two values get passed. So the first value that goes into the function will be 10. The second value that gets passed into this function will be 20. And the function will call these two values A and B. And then when we execute this, we will actually get the result of 10 plus 20. Now on the right here is the same example. Same functionality, works exactly the same, except now we're passing actual literal values as opposed to variables. If we take a deeper look into how this function works, here's a more visual representation. We call the function, parameters are passed and stored as variables. So the value 3 is the first value sent to the function, so it's stored in the first position of the function definition, and it's stored as the variable a. The second value, 11, gets stored as b. And then when we calculate the function, we'll see the result is going to be equal to a plus b, which are the first and second values passed into the function. And then we're going to return the result adding 3, the result of adding 3 and 11. Now we can do this in another way. We can use the Python Tutor visual editor, and this is just another way to look at this. So let's open that link and see how this works. So I've gone ahead and gone to the site pythontutor.com, and I've pasted this program into it, the same function, the add function with the result, and I'm going to return the result. But now when we run it, we get a little bit different visualization of how it works. And this is more of a graphical representation, I would say, of using the debugging mode in VS Code. But this is just another tool you can use to view how your program or your code is executing. So right now, nothing is executed. The next line to execute is line 1. So let's see what happens after line 1. After line 1, we create this global frame body, and we've created this function, and the function is called add a and b. But we haven't really done anything. We've just declared the function, essentially. The next step, we're going to add 3 and 11. And then we go back to the top to line 1 to start. We've called the function here, so now we're going back to line 1 to actually perform and execute that function. So we've executed the function, and now we're at line 2. And line 2 is again going to take those two values, add them together. And when we do that in the add function, we're going to add 3 and 11. We'll get 14. And then the next step, we're going to return the result, and that's when x will actually get a value. The return value is 14. And now we have executed the function. X now shows the value of 14, and we can print it here. So this is just another way, maybe an alternative to using the VS Code debugger, another tool you can use. So now let's take a look at some function exercises. So I'm going to demonstrate 3 exercises. The first one, I'll create a function that returns the product of two values, multiplication. Next, I'll create a function that determines if a number is even, and we can use the modulo operator for that. And lastly, I'll create a function that returns the max of 3 values. I'll need to take the grade of 2 values and compare it to the third. So let's get started with that. Okay, so the first exercise we're going to do is we're going to create a function that returns the product of 2 values. So for this to happen, I have to declare a function. So I'm going to say define product, and I'm going to pass 2 values, x and y. And within that function, I need to declare my body. Whoops, I got a squiggly mark there, so that means I missed something. I missed my colon. Next thing I need to do is, what am I going to do with x and y? So I'm going to say result, create a variable named result, and that's going to be equal to x times y. Then I'll return the result. So now when I call this function, I can say print, and I will just print, I gotta call the function, and I have to pass 2 values to it, 4 and 5. So those are the 2 values I will pass with my function call, and then I will print that. So let's run this now. So in this example, I'm printing it. I'm not actually making it a variable. I'll use it as a variable the other way, so in another example. So if I just run this real quickly, let's just run it without debugging and see if it works. And it did indeed execute the program, and it printed the result of 20. So the next example is we're going to create a function that determines if a number is even. So let's just wipe this one out, this example, and I will do modular. So def is even, and I'm going to pass just one value and determine if it's even. So now I'll create another variable. X is going to be equal to a, and we'll use the modulo function by 2. So let's print x. And I'll concatenate that, so I'm going to have to convert x to a string for this. Oops. So now what I'm doing is I just want to see what x is after I perform the modulo function. And essentially, if x is equal to 0, if I divide a number by 2, if I get a remainder, that means it's an odd number. If it's equal to 0, then I've got an even number. So if x is equal to 0, I will return even. And that needs to be a string. And then else, and I'll say odd. And let me correct my typing. I'll return even, and I'm seeing a check right here. I'm trying to compare, not declare. So I need to put the second equal sign there so I can compare x to 0. So now let me come here and I will get out of my, function body. All of this indented code only happens when the function is called. So now I have to call the function. So to call the function, I will say is, I'll just call this another variable. Is even. I'll call it even odd, and that's going to be, I'm going to call the is even function. So let me widen this out a little bit. So I have my function, so I'm going to say is even, and I will pass a value into it. So let's start with 12. And now I can print and I will put in string, here it is out here, string I can't really do that because I didn't declare 12 as a variable, so I can't print that variable. I wanted to print this number, but I really can't without making it a variable. I'm not going to bother with that, so I'll just print even odd. So let's run this and see how this works. So how this is going to work, I'm going to pass this value into my function call. My function is going to perform this, divide it by 2, and return the remainder, not the actual value. And we're going to print it just to see what the return is of the modulo. And then if it returns, if the number divided by 2 has a remainder of 0, it's even. And if it doesn't, it's odd. So let's run this and see what happens. And let me scroll my terminal up a little bit. X is equal to 0. So 12 divided by 2 has a remainder of 0. And it's even. So now let's execute it again and test it for an odd. 1, 1, 1. 4 ones. Okay, that works too. Now if we run this again, run it without debugging. And now x, the remainder of 1, 1, 1, 1 divided by 2 is 1. So it's an odd number. So now let's do the last one. Let's create a function that returns the max of 3 values. Let's get rid of all of this, max. And we're going to pass 3 arguments. So I'm going to do A, B, and C. So for this to work, I need to think about what do I want to do? So kind of what I want to do, I mean, there's already a max function built into Python, but we're going to create our own. So if I pass 3 values, I need to compare 2 of them, store the bigger of those 2 into a variable, and then compare that new variable to the 3rd value. So the first thing I'm going to do is find which number is bigger between A and B. So let's just do if A is greater than B, then what should we do? I'll create a new variable. I'll just call this X is going to be equal to A. And if A is not greater than B, X equals A. Else, X will be equal to B. So now I've created this new variable in my function body called X, and it's going to be the greater of A and B. So now I can do the same thing by comparing X to C. So if X is greater than C, I can, well, I'll just create I'll return X. I'll return X. And else, if X is not greater than C, I will put my colon here, and I'll return. I will return C. So let's give this a test. And let me see, max value. And that's going to be equal to, I'm going to call the function max, and I'll pass 3 values into it. 10, 20, 30. And this should return the maximum of that, and now I can print it. And I'll print max value. So let me close this terminal so we can take a little bit better look at this program. So once again, I've created my function. The first step is to compare A to B and store the larger of the 2 as the variable X. Next, I can compare X to C, and the larger of those 2 will be returned. If X is greater than C, I'll return X. If it's not greater than C, I'll return C. So let's run this and see what happens. And now we've created a function that returns the maximum of 3 values. Our next exercises are going to be to write a function that calculates the area of a rectangle and then the perimeter of a rectangle. Then we'll write a program that prompts the user for the length and width and then calculates the area and the perimeter. Remember, the input function returns a string. So let's take a look at what that looks like. Okay, so the first thing I need to do is I want to create my area function. So I'm going to define area, and it's going to have 2 values passed into it. And I need to put my colon in there. And for this, I'm going to say area is going to be equal to A times B. And then I can return area. And I'm pretty sure I got this right, but let's test this anyway. So I'm going to print area, and I need to pass 2 values, 5 and 4. That sounds good. And let's see what happens when I run this. I can bring my terminal up, and it did indeed take the values 5 and 4, pass it into my function, and print it. So now let's create the function for perimeter. Get rid of that. And that's going to get two values also. They can be A and B because these are different functions, and we have a slide that talks about that a little bit later. So I've created my perimeter, and now I say perimeter, and that's going to be equal to A plus B plus B. Add them all up. There is my perimeter. And I can return. So now let's call this equals. I don't do area, I don't do perimeter. Perim is going to be equal to, I gotta call the perimeter function. So let's do this, perimeter. And I'm gonna pass two values, 6 and 3. So I'm gonna pass those two values into my perimeter function, and then let's print perim. So let's run this and see how this works. And I would expect to get 12 plus 6, and I should be getting my perimeter as 18. So now let's look at the last task, which is to prompt the user for the length and width and then calculate the area and perimeter. Well, I've already got the functions for the area and the perimeter. So now let's call on the input function. So I've declared these. So now let's just, I don't know whether I want to put the input call above or below the functions. Generally, I like to always put functions first, so I'm going to do my input function after the function definition. So let me say length is going to be equal to input what the heck happened there? I hit a funky key. And then I'll do the same for width. And I will enter the width. Try to keep my capitalization consistent. Okay. So now I'm going to prompt the user for this, and then I can call. Now instead of passing perimeter, I'm going to pass to get the perimeter. I'm going to pass that, and then I need to get the area. It is going to be equal to calling the area function. And now I can put some print statements in here. So my first print is going to be and I will concatenate area. And then I can do another print. Perimeter is going to be is, and concatenate. Do that string. So I've got those. Now there's one thing I kind of forgot about this. Length. I'm going to pass this. Remember, length is stored as a string, so when I pass this into the function call, this function is going to need an integer to do those calculations. So let's just convert those right now. So length is going to be equal to int. And, it can be int, it could be a float. Actually, a floating point decimal would be better. We might want to pass decimals into this. So we'll change length to a float this way, and then width, we'll do the same thing with this. Float width. So I'm going to prompt the user for these two values. I'm going to convert those two values to floating point decimals. I will pass them in a function call for both the area and the perimeter. Let me scroll this down so we can look at the whole program here. I'll pass them into either the area or the perimeter. And then lastly, I'm going to print the result. So let's run this and see what happens. Enter the length. I'm going to say my length is equal to 5 and my width will be equal to 2. The area is, notice these are floating point decimal numbers. We get the dot with the 0 after it. 5 times 2 is indeed 10. 5 plus 5 is 10. 2 plus 2 is 4, so the perimeter is 14. Okay, so what we did was we created some functions, but all we really did was we maybe created more work for us because we had to create the function for something that we could have just written the code for directly. But the beauty of functions is we can save them for reuse. So we have modules stored in our library or our library/site packages folder, and they can be stored local to the script being run as well. And that allows us to reuse the code. So here's an example of where you would put your functions if you wanted to access them all the time. Another thing you can do is, here's modules stored in the library site packages folder. But for portability, if you're going to be using this on multiple computers, instead of having to copy that file into those folders, another thing you can do is you can store your functions in the same folder as your program. So this would be the program calling the rectangle function. So let's take a look at how that looks with our earlier code. So here's the custom function, get perimeter, get area. So let's take a look at this. So here's an example of, we have this module saved as rectangle functions. Now if it's saved in another program, for our code to execute it, we have to tell our main program that you need to load the instructions from this module. And then if we tell it to import these two functions, now it knows how to get that. So let's take a look at this in VS Code as how that works. Okay, so I've got VS Code running, and here's our original program with the two functions. Now if I want these functions accessible by other programs for reuse, what I can do is I can just take this and cut it out of here. And I'm going to have to create a new file. So I'll create a new file. And let me just call this functions, my functions. And I'll create it. And I need my functions to be saved in the same folder as my main program, which I call exercises. So as long as my functions is in the same folder as my main program, this will work. So now I can go back to exercises. So my functions, well, now I have to paste the values into it. So there's my functions program. It's the two function definitions that we use. Now in my exercises program, I don't need that code here. What I do need to do is I need to tell my main program where to get these instruction sets. So in my main program, and actually, can I split this? Let's look at that. So I want to bring my functions over here. So here's my test program, and I can minimize this also. So now I've got both screens open. So my main program is going to prompt you for this. But notice here I've got squiggly lines. It doesn't know what area or perimeter is. So let's make sure that our main program knows where to find these two functions. And then I can say the end separator will be an empty string instead of a new line. So the first instance of this, I'm going to print hello and then world. But if I wanted to print it with an end separator, of I don't want that new line character as my end separator. When I print hello, I'm not going to put anything at the end of it, and then I'll print world. So the second example up here, hello world, all one line, no end separator. Now the scope of the variables, parameters and variables that are assigned in a function, in a called function, are said to exist in that local scope. Variables that are assigned outside the functions are in the global scope. So let's take a closer look like this. Code in the global scope outside of all functions cannot use any local variables. However, code in the local scope can access global variables. Code in a function's local scope cannot use variables in any other local scope. And I can reuse the same name for different variables if they are in different scopes. So let's take a more detailed look at what these scopes look like. In this example, we have a global variable, Palo Alto, and that's going to be equal to 33. If I want to print something, I can call the Palo Alto function here because it's global. So a function can call a global variable, and I can create a local variable. What I can't do is I can't access the value Fortinet because it's inside of a function. It's in a different scope. And that's why I'm getting this error. When I try to print this, I see the squiggly lines here saying this, I'm calling Fortinet globally, but the actual value is stored in the local scope of this function. Now, code in a local scope can access global variables. So here's my global variable. This is fine. I can see this. And now Fortinet is inside of this function. So total devices, I call the total devices, but I still can't access Fortinet from here. That's still an error, but I can indeed access a global variable in a local scope. Code in a function's local scope cannot use variables in other local scopes. So here's two scopes. I've got a function called total devices. I've got another function called Fortinet devices. This variable is not in this function call. It's up here, so I can't access that value from this scope. Here's another example of local. You can use the same name for different variables if they are in different scopes. So here I've got these same values, and using these values globally, and I'm using these locally. These are different instances of those values. If I wanted to make a variable out of a local scope global, I can add the keyword global before it. And now what I'm doing is I'm declaring this value Fortinet as a global value. Now when this first line says Fortinet is global. Now when I assign a value to it, this value is now accessible from the global outside of this local function, this local scope. Okay, so I've got my main program separated from the actual function, and the cool thing about this is I can write multiple programs to access these two functions. The problem I have now is my main program does not know anything about this perimeter function or the area function. It's no longer in here. So we need to tell our main program where this is. So to do that, I have to do the import. So I'll say from my functions, going to import. I will import area and perimeter. Now I'm still getting this error here, and this is intentional because you could run into this. And what's happening here is I've expanded the Explorer window, and you can do that just by clicking this right here, the top left, the two files here. And what's going on is the Explorer is actually in the folder called Python. It's actually not in the correct folder. It doesn't really show the path here. Maybe Python CSV is the actual folder that's open. That's the working directory that VS Code is working from. So if I want to change that, let me go ahead and save this program first. I'm going to save it. I'm going to save my exercises with the new function. But I need to open the correct folder. So I'm going to go to open the folder, and now I need to, instead of being in this folder, I'm going to open my Python folder. This is where it's stored, and I'm going to open Python. It refreshes my program, and now it actually, since I'm actually running VS Code from this folder here, which is where I've stored my two programs, now it can find the functions and I can execute it. So let's take a look at that. I'm not going to install additional debuggers. I'll just run it from here. And now I'm being prompted for the length, and the length I will say is, let's make it 5. And the width will make 2 again. And now the program is executing. I am retrieving values from these functions, and once again, the beauty of this is I can write multiple programs to access this code. Now if I imported a module into Python, then I can verify it by entering the Python interactive mode, simply by typing Python in a command prompt, and then I can call the help function. Help, open parentheses, close parentheses, and then once I'm in the help menu, I can type modules, and it will list all the modules that are installed for this version of Python. Functions have keyword arguments. Most arguments are defined by their position in a function call. Keyword arguments are often used for optional parameters. The print function automatically adds a new line character at the end of the string. So the print function has a keyword argument called separator, or sep, and end. So let's take a look. So if I wanted to print something with a keyword argument, I can print hello, comma, and then I can say the end separator will be an empty string instead of a new line. So the first instance of this, I'm going to print hello and then world. But if I wanted to print it with an end separator of, I don't want that new line character as my end separator, when I print hello, I'm not going to put anything at the end of it, and then I'll print world. So the second example up here, hello world, all one line, no end separator. Now the scope of the variables, parameters and variables that are assigned in a function, in a called function, are said to exist in that local scope. Variables that are assigned outside the functions are in the global scope. So let's take a closer look like this. Code in the global scope outside of all functions cannot use any local variables. However, code in the local scope can access global variables. Code in a function's local scope cannot use variables in any other local scope. And I can reuse the same name for different variables if they are in different scopes. So let's take a more detailed look at what these scopes look like. In this example, we have a global variable, Palo Alto, and that's going to be equal to 33. If I want to print something, I can call the Palo Alto function here because it's global. So a function can call a global variable, and I can create a local variable. What I can't do is I can't access the value Fortinet because it's inside of a function. It's in a different scope. And that's why I'm getting this error. When I try to print this, I see the squiggly lines here saying this, I'm calling Fortinet globally, but the actual value is stored in the local scope of this function. Now, code in a local scope can access global variables. So here's my global variable. This is fine. I can see this. And now Fortinet is inside of this function. So total devices, I call the total devices, but I still can't access Fortinet from here. That's still an error, but I can indeed access a global variable in a local scope. Code in a function's local scope cannot use variables in other local scopes. So here's two scopes. I've got a function called total devices. I've got another function called Fortinet devices. This variable is not in this function call. It's up here, so I can't access that value from this scope. Here's another example of local. You can use the same name for different variables if they are in different scopes. So here I've got these same values, and I'm using these values globally, and I'm using these locally. These are different instances of those values. If I wanted to make a variable out of a local scope global, I can add the keyword global before it. And now what I'm doing is I'm declaring this value Fortinet as a global value. Now when this first line says Fortinet is global. Now when I assign a value to it, this value is now accessible from the global outside of this local function, this local scope.